So for our first example of area function, we're going to look at this function f of t, which is given below. Now we generally just call t a dummy variable in this case because it doesn't really matter what this variable is. The area under this curve will be determined by another variable x. So this could be s, this could be y even, or whatever. It doesn't matter. Okay, so the area function is going to be defined as, let's zoom in here a little bit, big A of x, okay, so capital A of x, area under the curve from 0 to x of f of t. So for example, we can see why this is a function. As we move from t equals 0 to t equals 12, the area under this curve is going to change, okay? It's going to increase, 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 and then I'm going to use red for below the t-axis. Then the area is going to start to decrease because all of this below is going to cancel out this green area. So A of x, okay, let's just use, let's actually use purple for A of x. A of x changes as we go from left to right, okay? It starts out increasing, then it decreases some more, so I'm going to use some more red here, okay? And then the area starts to increase again right here, okay? So you can see why A of x is a function, is because it changes. The area under this graph changes as we move from t equals 0 to t equals 12. So that's what A of x is. It's a function defined as the area under this graph from 0 to x. So here's our first question. What are the relative minimums? Now I recorded this before and I realized that I made a mistake here. Let's talk about what a relative minimum is. It's where the graph of a function, so let's just say a parabola for example, goes from decreasing to increasing. What are the relative minimums of A of x on the interval 0 to 12? So what we're really talking about is where does the area of this function go from decreasing to increasing? Where does the area go from dropping to increasing? And if we just look at the graph, we can see that the graph starts decreasing here. The area under this graph between the graph of f of t and the t-axis goes from decreasing to increasing not until t equals 10. At t equals 10, the area will be canceling, it'll be continue to cancel, this red area will cancel this green area up until 10, then it'll start increasing again. So I'm going to put an orange circle around t equals 10, and that's where the area starts to go back up. So let's read this together. This can only occur whenever the graph goes from below the t-axis to above the t-axis. This is because the area as a result would go from decreasing to increasing, hence a relative minimum. Let's underline that in orange. Okay, this only occurs at t equals 10, okay? Now, I do want to make a note. Notice that at t equals 7, the function almost goes from below to above the t-axis, but it doesn't. The area under the curve of f of t continues to decrease at that point, and therefore there is no relative minimum at t equals 7. So let's underline that. There is no relative minimum at t equals 7. Let's explain that. Okay, so at t equals 7, what happens? Okay, the area continues to decrease. Remember, area is net change, so anything below the t-axis will count as negative. The area continues to drop or become close or more negative, decrease up until 7, but it doesn't. The graph doesn't hop above the t-axis. It actually goes back down and continues to decrease. So there is no relative minimum there. It only occurs where it actually crosses the t-axis and goes from negative to positive, because the area would start increasing there, and that's at t equals 10. So that's it for this part A of area function where its relative minimum occurs at t equals 10. Next, we'll look at where its relative maximum occurs. If you have any other questions about this example, let me know.